Good day, my name is Microcontroller, number ID EB20023. This is our mini project for microprocessor and microcontroller fundamentals. My teammate is Hafiz bin Abdul Baki, and here is the codes. This is our demonstration video. So we have used two switches as input and a 7 display as output. So in the codes, here is stating the register and the port C. This is our scan command, scan instructions. So we load the port C, which is connected to the switches. So when the right switch is turned on, it becomes 0 1. The left switch becomes 1 1 1. So this is the bit 0 for port C, and this is bit 1 for port C. So when the port C is equal to 0, which means no switches is on, it branches to pattern 1. For when the switch is turned on, so turn on the right one. So this now the port C becomes 0 1. So it compares and then it branches to P2 pattern 2. Same is for pattern for 1 0, which is 3 pattern 3, and then pattern 4 is 1 1. So here is the pattern. So the Y is loading the data 1. The data is in data 1, which is here, which is the array for our which is an array for the pattern to be displayed on the 7 display. So Y is load the data, and then LDD and load the data into A, and it will if the array reaches a 0, so BEQ, so when the array when loading until 0, it will branch back to scan. So it scans again after completing the whole array of data, after displaying the full pattern. If the data is not equal to 0, this will skip, and then A will be stored onto port B. Port B, which is the 7 segment. 7 segment is connected to port B. And then it will branch to a delay. There are two delays. One is approximately 1 second, and the second one is a little shorter than 1 second. So that for the free patterns, for pattern 1 and pattern 4, it will be much faster. And then pattern 2 and 3 will require the 1 second delay between each letters to properly observe. After finishing the delay, it will increase Y. So in the array, when 8 is loaded into is loaded onto accumulated A, it will skip the punch equal back to scan, and it will store the number 8 onto the port B, which becomes the 7 segment, and then you will run the delay, and then increase Y to load the next pattern, the next 7 data, and then it will always branch back to P33, so back to LDDA. So the delay for the 1 second delay, since there is a limit for the accumulator B to be used as a counter, so we decided to just use 2 more of the same code, which loops back to no op here, and using 3 will get us approximately 1 second, but afterwards, because I am recording, so the computer will run slower. Same for the short delay, and here is the data. So now we will run this code. So now my switches is at 0, 0, so it should be pattern 1. So pattern 1 is like this. So next is pattern 2, which is 0, 1, 0, 1. For our code, it is designed so that it always loops. It cannot interrupt when it is loading the data. So now it is displaying my number ID EB20023, but because my CPU is using a lot, so it is running a lot slower. But if run under no extra load, it will be much faster. So just now it's E, now it's B2. There are 2 zeros in my ID, so 2, the second 2, and then the 2, 3. So now we want to check pattern 3. So pattern 3 is 1, 0. So pattern 3 is EB20043. Same, there are 2 zeros, so that it displays the second. Now it's 4, 3. It looks back to E. So the next one should be pattern 4. So pattern 4, which will be both switches turn on, 1, 1. So pattern 4 is a phone number for my teammate, Hafiz. Zero 195807202. So for pattern 4, he is using, because the short delay is also not enough. The short delay is used on pattern 1 and pattern 4, but pattern 1 requires a shorter time. So we compromise and use a short delay, only FF, which is only 64. So pattern 4, which requires a longer time, uses 2 branch subroutine delay 2. And that is all for our demo.